Thank you, Manshi, for the introduction. All right, thank you everyone for attending, and thank you for Dr. Chen to invite me to discuss this extraordinary and really interesting work. I really enjoy reading it, and I think it's super interesting and important. So because I think that many of the audience are not purely from economics background, so I'm going to water down my discussion a little bit in more like a layman's terms. So maybe I'm going to lose a little bit technical beauty of Dr. Chen's work, but I hope I grasp the intuition right. So the key fundamental trade-off we are really thinking about these days, particularly through migration, is that if we reduce the intercity migration from point A to point B, we're thinking about the two competing effects. One is that you will have a decrease in number of COVIDs in destination, which is a good thing, but there's also a decrease of local economic activity, which is a bad thing. So really, we're really trying to think about how do we optimize this trade-off from societal perspective. So let's think about it from a visual perspective. So this is actually, I also grabbed this figure from Baidu migration. This is where people migrated to from Wuhan until I think the end of February. Actually, let me take it back, until the end of January. And the question is that, some city-to-city migrations have different or more or less impact on COVID infections and the destination economy. So we're really trying to think about, among all those between city-to-city links or migration links, what kind of links should we restrict? And we probably want to restrict those links with heavy COVID impacts and low economic activities, and preserve the others. So that's kind of, I think, the intuition there. And in order to optimally calculate this trade-off, the first thing we need to do is to estimate the intercity migration impact on COVID. So when you understand when more people flow from city A to city B, that additional number of people, how many additional COVID cases it's going to bring to the destination city. So here, Dr. Chen and his co-authors, they actually use very parsimonious empirical specifications. They model a city's COVID infections as sum of intercity migration effects and within city traffic effect. So it's very simple. A city's number of COVID cases is just where it comes from two components. One is that how many cases come from the outside city, and second is how many cases occur like organically from within the city. Then for the data, they use Baidu migration. They actually provide the migration data for both between and within cities for the past few months for the entire China. Now, in order to estimate the impact, they use a very clever trick in economics. So they use past year migration and weather conditions in other cities as the clean and exogenous, what we call instrumental variable variations to estimate the effect. So what does that mean? So if we think of it intuitively, we're kind of going back to the cliche causality versus correlation problem. So if you think about intuitively, when you actually just look at a correlation between a city's number of COVID impacts on one side and how many people migrate to the city on the other side, there's always a correlation versus causality problem, because when the city's infection rate goes up, maybe few people want to visit the city, or actually it could go the other way, because it's actually because more people visit the city, then the city's infection rate goes up. So those two effects kind of tangled up. So in economics, we have this clever technique called instrumental variable approach, that is to mimic or to find those kind of natural experiments. So ideally, we want to say, hey, in a natural experiment world, we want to hold everything else constant. We just randomly change the number of people who visit the destination city, and looking at how does this random variation affect the number of COVID cases on the other side. And that's exactly what Dr. Chen and his co-authors are doing. So they find some random variation. They think about it as, the past year migration number is kind of a random variation determining this year's migration number, as well as, the origin city's weather condition will also randomly affect the number of people who want to visit a destination city. So it's kind of through those random variation, they try to mimic a natural experiment so they can estimate truly what is the intercity migration effect and what's its impact on number of COVID.